Dear students, today we are going to discuss about Hammerstein type equation. In the integral equations, this is another type of integral equation. How to solve this equation, that we'll see now. See, many problems in the physics may be reduced into a linear integral equation, which are nothing but called as a Hammerstein type equation. So which is reduced to non-linear integral equation, then those are nothing but called as a Hammerstein equation. Hammerstein equation will be in the form of like this: phi of x equal to integral a to b k of x comma t f of t comma phi of t dt. Let us take this as equation 1. You have to remember that the equation will be of this form. You see that kernel will be there, and there will be some function which is nothing but which is having t and phi of t. Means you may have t, phi of t square, phi of t cube, and so on. Where k of x comma t is a kernel and f of t comma phi of t. So I am taking as f of t comma u. U is nothing but any function, maybe is phi of t or anything else at the given functions. And you know already the phi of x is nothing but unknown function. This unknown function, you have to find out the value of phi of x. So therefore, now what we are going to do, we are going to take k of x comma t, the degenerate kernel. Already we have done the degenerate kernel problem. So that degenerate kernel will be of the form like this, that is aix ba of t. This is some function which is nothing but maybe sin x, cos x, anything else, right? That you can have in the problem. So meanwhile, we will take the degenerate kernel in the form of like this, that is aix and bi of t. This is called as degenerate kernel. We will substitute this degenerate kernel here. Now when we substitute that, this becomes in the form of like this. Means equation 2 is substituted in equation 1. Summation I equal to 1 to m aix bit f of t comma phi of t is as it is. And taking this one the outside of the integral a to b, because this is in the function of t. So we are integrating with respect to dt. So we are taking as ba of t f of t comma phi of t dt. Now this a of x is as it is, and this entire thing will take it as some ci. Means ci is the integral, ci is nothing but the integral of this whole thing. Now after taking that integral, now we will try to write in the form of like this. Okay, so integral we will try to write that. Now where ci? So where ci is equal to this integral a to b bi of t and f of t comma phi of t dt. This is what we got, where I is nothing but equal to 1, 2 and so on m. These are the I values. You may get C1, C2, C3 and so on up to the m values. Now after getting these all values, we'll substitute this one. After getting these all values, means substituting the unknown constant. These CIRs are unknown constants. These are unknown constants. After getting these unknown constants, we'll substitute this in equation 4. The expression equation 4. This is the equation 4 into an expression of ci we obtain m equations. We obtain m equations containing we'll get m equations because ci equal to 1 to m now. So m equations containing m unknowns, that is c1, c2 and so on up to cm. Okay, so if there exists the solution of this system, then this leads to the, if there exists a solution there exists a solution of this system. We'll get a system that is if there exist m numbers, then C1 naught, C2 naught and so on, Cm naught. Okay, such that its substitution in equation 4 leads ultimately to the solution of the given integral equation, or we'll get the integral equation solution. Means you may get all the values of c's, that is unknown constant, from I equal to 1 to m, such that you may get c1, c2, cm, or you may get m equations such that you are going to solve each and every equation in order to get c1, c2 and cm. After getting these all values, we'll substitute this this c1 and c2 and so on in equation 4. You will be getting the ultimate solution of the integral equation. Now let us see how it works for a problem. By taking one problem, we'll try to find out the solution of Hammerstein equation by doing a small problem which gives us 4 marks in this paper. Okay, so first we'll take that. Now solve the integral equation. Phi of x equal to lambda into integral 0 to 1 x t phi square of t dt, where lambda is a parameter. Now this is the equation which is given. Now solution, we'll try to find out the solution. You should understand the equation. By seeing this equation, you try to judge that whether this equation in which form, Hammerstein form equation or any type of equation, which type it is given, that you must remember, that you must recognize. Then only you can able to apply the solution or method. You can apply the method for that. So phi of x is equal to lambda into integral 0 to 1 x t phi square of t dt. You should understand here this is phi square of t is given, which is in the form of like k of x comma t kernel into some function f of t comma phi of t. So this is nothing but in the form of a Hammerstein equation. You must recognize the equation in which type it is given. So therefore the given equation is nothing but Hammerstein type equation. Now we'll try to solve this equation by taking phi of x equal to, I am taking the given equation phi of x equal to, I'll write this lambda here and I'll write the x outside and integral 0 to 1 the t phi square t dt. Now you should understand t phi square t, this entire thing I'll take it as like c, as accordingly for the theory what we have given, the same thing. So therefore phi of x is nothing but equal to lambda x and the c. You take it as this as equation number 1, where c is equal to integral 0 to 1 t phi square t dt. Now this entire term is changed as c. Now this c, now we'll try to find out the value of c by taking the phi square of t value. Now where we'll get phi square of t? We'll get phi of t value from here. Phi of t will get, that is phi of t is equal to lambda tc. Now we'll try to substitute this value in this. So we'll take c is equal to integral 0 to 1, this is t into phi square of t, means lambda tc whole square dt. Now this phi of t is nothing but phi of x. Phi of x means phi of t, wherever x is there put t. Now you will be getting as t square and lambda square. So I will write as lambda square c square integral 0 to 1 outside, and this is t square and this t. So this will be t cube dt. Okay. Now if you integrate this, this is lambda square t power 4 by 4 under 0 to 1. Okay. Now after this, now you can understand this is 1 by 4. 1 by 4 and the other one is minus. Upper limit is 1 and lower limit is 0. So you will be getting as lambda square c square by 4, because 1 power 4 is 4. The other one is 0. So lambda square c square by 4 is given. Now this one I will take to this side. Means c, I will take this side, minus lambda square c square by 4 is equal to 0. I have taken this term to the left side. In this I will take c common, c 1 minus lambda square c by 4 is equal to 0. Now you should understand there are two terms here. One is c is equal to 0, the other one is this is equal to 0. So I may take it as c is equal to 0 and 1 minus lambda square c by 4 is also equal to 0. Okay. So therefore this implies c equal to 0, this one, and lambda square c by 4 is equal to 1. This term has taken that side. Now c will be what? C will be 4 by lambda square. Now I will take this as c1, I will take this as c2. So therefore what is that now? We'll consider now let us consider c1 equal to 0, and I'll take this as c2 is equal to 4 by lambda square. Now we'll substitute c1 equal to 0, c2 equal to 4 by lambda square in the equation here, this one. So substituting c1 and c2 in equation 1, we get, so when c1 is 0, you can understand c1 is 0, this entire term will be 0, therefore I will take phi 1 of x. When c1 is 0, phi 1 of x is 0, and the c2 is 4 by lambda square. So I may write as phi 2 of x is equal to lambda x into 4 by lambda square. Now this one lambda will get cancelled, will get 4x by lambda. So phi 2 of x is what we got here. The phi 2 of x is 4x by lambda. So therefore phi 1 of x is equal to 0, phi 2 of x is equal to 4x by lambda. Now this is how we can solve the Hammerstein type equation, similar to the form of degenerate kernel. But here is, you should remember the question which type it is given, whether it is given as a directly degenerate kernel or it is given as Hammerstein type equation, so that we can solve these two. So we can do many more problems regarding this type, so that you can understand very easily this problem. It gives for 4 marks. Thank you.